Hello, and today's learning target is I can use the Pythagorean theorem to solve word problems. Let's take a look at the first example. How far from a house does a 25-foot ladder need to be to reach an 18-foot window? Well, let's draw ourselves a picture so that this is a little bit easier to think about and then solve. So I'm going to draw here a house, and then with the roof, fix that roof, there we go. And then it needs to reach a window, right? So here's the window, here will be the door on the house, and there we go. And then I need to draw a ladder here. So how far from a house does a 25-foot ladder need to be to reach an 18-foot window? So this is a 25-foot ladder. Let's write 25 a little bit better. 25-foot ladder, and here's the 18-foot window. So we need to figure out here what this distance is, this leg there, if this is the right triangle, what that leg would be, right? Because we know the hypotenuse, the diagonal, is 25. Again, that should be the longest side, and it's the diagonal side, so that's this side. So we actually have to solve in red here, A. So how far from a house, and this would be the distance from the house, does the ladder need to be, so this spot right here, to be able to reach that 18-foot window. So let's set this up using the Pythagorean theorem. So a squared is the side that we want to find, plus the other leg would be 18 squared, has to equal 25 squared. So again, if we remember our perfect squares, we remember that 18 squared is 324, and then 25 squared is 625, and that one I know we didn't memorize, but that's a good one to also know. And let's solve for a, so let's subtract 324, and so I get a squared equals 301, and let's take the square root of both sides, and we'll round to the nearest hundredth. So the square root of 301 is about 17 point, so here what I get is I get 17.349. So to nearest hundredth, that'd be the second digit. We have to look at the third digit, and that 9 makes that 4 round up. So my answer here will be A is equal to 17.35 feet. So it must be 17.35 feet away. So if you think about it, does your answer even make sense? Well, this is a leg, so the leg should be shorter than the 25-foot ladder, because that's the hypotenuse, and that makes sense. And then is it reasonable? A leg of 17, a leg of 18 feet, would those be legs for a 25-foot or 25-foot hypotenuse? Yes, that makes sense. And my drawing might not be as accurate to look like 17.3, but that's what it comes out to be, and it's pretty accurate, pretty close. So that would be our answer for number 1. Let's take a look at number 2. A carpenter is building a house and wants to make sure it is square, or that it has 90-degree angles. The house is 25 feet long, little typo there, 25 feet long, and 35 feet wide. How long should the diagonal of the house be to prove that the house is square? So let's go ahead and let's look at, if we here have a house, right, 25 feet long and 35 feet wide. So 25 feet long and then 35 feet wide. So we want to make 90 degrees here in the corner. So what I can actually do is I can cut this rectangle in half, that house in half, and if I can draw a straight line, whoa, stylus slipped. How long should the diagonal of the house be to prove that the house is square? So again, we have to find the diagonal, and the diagonal is always known as the hypotenuse, which is C. So we got to figure out how long that should be to prove that the house is square. So I'm going to set this up in the Pythagorean theorem and say, a squared plus b squared equals c squared. So here, 25 squared plus 35 squared has to equal that c squared. So 25 squared is 625, plus 35 squared is 1,225. And then 625 plus 1,225 is 1,850. And then to solve for c, I take the square root and round it to the nearest hundredth. So let's take the square root of 1,000 850, and I get 43.011. So that 1 here makes the 1 stay as it is, so I don't round up. So I get C is equal to 43.01 feet. And I can label it with feet, F-E-E-T, or I could use the little mark that represents feet. So 43.01. So again, you have to ask yourself, is this answer reasonable? If I have a leg that's 25 and 35, and I'm making a right triangle, could the hypotenuse be 43.01? Well, yeah, that makes sense because it definitely should be longer than 25 and 35, so that does make sense. Let's take a look at the third example. Will drives 5 miles north and 9 miles east. In a straight line, how far is Will from his starting point? So let's draw a picture because pictures always help. So Will, here's where he starts, drives 5 miles north. So north would be up. That would be 5 miles. MI means miles. And then he drove 9 miles east. So I'm going to go 9 miles east, and that would be to the right. So we got to figure out here the diagonal, how far is he from his starting point? So let's figure out C, that distance that he traveled. So I'll set up 5 squared, because that's a leg, into the Pythagorean theorem, plus 9 squared equals C squared. Good, right? And I knew that that was the diagonal because this forms a 90-degree angle, and C is always the diagonal here, the longest side. And 5 squared is 25, plus 9 squared is 81, equals C squared. 25 plus 81 is 106, equals C squared. And let's take the square root. And the square root of 106 rounded to the nearest hundredth is, I got 10.295, so that 5 makes the 9 round up. So that becomes 10.3, and we could write a 0 afterwards, but we really don't have to, so I'm not going to. So C equals 10.3, and again, that's to the nearest hundredth because that 9 made that 2 round, or that 5 made the 9 round up, which makes then the 2 round up. Yes, and if I think I said that correct, right? The 5 makes the 9 round up to a, right, 10, which turns to a 0, which then makes the number in front of it, the 2, round up. Okay, let's look at our last problem here. Okay, Curtis swam across the river. The river is, and there was a typo there, let's change that 300 to 400, is 400 meters across. Because of the current, Curtis winds up 150 meters downriver from where he started. How far did Curtis actually swim? So let's say we have a river here, and there's water in that river, right? And Curtis starts about right here. And we know that the river is this distance across is 400 meters. And he's swimming, but he swims downward because of the current, right? The current's going downward. And so really, he's traveled this distance right here, 150 meters. Well, we need to figure out how far he actually swam, right? So the distance he covered was 150 meters down the river. So we can make this triangle right here, go across, and assume that this is a right angle. So we have a triangle here in blue, and we know if this side over here is 150, this distance over here is 150 meters. So we can set this up to figure out the distance he actually swam, right? Right here for the diagonal, which would be C, because we know here this leg is 400, this leg here is 150. So let's set that up and plug that into the Pythagorean theorem, which is A squared plus B squared equals C squared. So I have 150 squared plus 400 squared equals C squared. So 150 squared is 22,500 plus 160,000, which is 400 squared, equals C squared. So 182,500 equals C squared. And now to undo that, I'll take the square root and figure out C. And I get rounded to the nearest hundredth, so grab your calculator. Square root of 182,500, which is, I get 427.200, so that 0 keeps that 0 as it is. So the distance is 427.2 meters. So that's a lot of meters swam. Way to go, Curtis. Thanks for listening. Have a great day. Good job on those word problems. Bye-bye.